Dr. Joao. So Joao Onofre Pereira Pinto. I call you Joao, but normally is Dr. Pereira, no? Isn't it? Joao.
Yeah,
Dr.
it's Joao. Just call me Joao, yeah.
Okay. Senior member IEEE, was born in Valparaíso, Brazil. He received the BS degree in electrical engineering from Sao Paulo State University, Brazil, in 1990. The MS degree in electrical engineering from Federal University of Uberlândia, Brazil, in 93, and the PhD degree in electrical engineering from the University of Tennessee, Knoxville, United States, in 21. From 1984 to 2021, 94 to 2021, he was a faculty member with the Federal University of Mato Grosso do Sul, Campo Grande, Brazil, where he served as a dean of the College of Engineering from 2013 to 2017. He was also the founder and director of BAT Lab, a research laboratory focused on power electronics, artificial intelligence applications, electrical drives, and energy systems. Since 2021, he has been on leave from his position as professor with the Federal University of Rio de Janeiro, Brazil. He is currently a distinguished research staff member with the Oak Ridge National Laboratory, Oak Ridge, Tennessee, USA, where he served as a group leader of the Grid System Architecture Group with the Grid System and Control Research Section. His work focused on advancing resilient, secure, and sustainable electric energy systems through innovative application of power electronics, grid modernization technologies, artificial intelligence, and distributed energy resources. Dr. Pinto has authored and co-authored more than 230 technical publications in journals and conference proceedings. His research interests include power electronics, grid system architecture, artificial intelligence applications, electric systems, microgrids, distributed energy resources, and electrical machine drives. He has also held numerous leadership positions within the IEEE Power Electronics Society, including serving as a chair of the steering committee of the IEEE Southern Power Electronics Conference, SPEC. So, yes, we are the organizer of next SPEC in Cartagena 2026. Thank you very much, Dr. Joao. The floor is yours.
Thank you. Thank you, Jose, for the nice introduction. Thank you so much.
It's a pleasure.
Yeah. Before I start, I would be good if I could have like a can you everybody hear me?
Yes, you're audible, Joao.
Yes.
So I would like first, before going to the presentation, to the audience, what's like the background of most of you, like undergrad student, master student, PhD student? What's the areas of interest? How is it there today?
Sergio, tú conoces mejor el grupo.
We are some undergraduates from electronical and electrical engineering, and some professionals too. We have both audience.
Okay. So, all right. I think maybe, I'm not sure if the content that I have to present to you today is the content you were expecting, but feel free to ask me whatever you feel like asking. And then if something I don't cover that you have curiosity or you wanted to know, ask me. If I know, I will I will respond to you. And if I don't, I can always find the answer for you later. Okay, so let me share my slides here. Can you all see my slides?
Yes, it is visible, Joe.
It's
Yes.
changing. It's changing.
Yeah, it's changing.
Okay, good. So we're good then. Okay, so let me introduce myself. As Fernando said, and as you know, I mean, as you heard from his introduction, and also maybe you can find out through my accent, I'm from Brazil. I'm originally Portuguese speaker. My second language, which is not so good, but is English. It is not so good, but I think it's better than Spanish. I try to communicate with me and Jose when we are drinking in a bar. We can speak Spanish very well, right, Jose? But
Very, 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 it's true. Thank you very much.
yeah, we can speak Portuguese, Spanish, and then we can understand. Now, when you and but I don't think I can give you this talk in Spanish. I apologize for that. So that's
No,
why.
no, no, no hay problema. Creo que han sido reuniones muy productivas, pero tú me
Yeah,
entiendes.
yeah.
Okay.
So then I'm gonna give the talk in English. And if you don't understand what I said again, because my accent is strong and I'm not very fluent in English, you can always stop me and ask. Okay, let me talk a little bit of myself. I'm as I said, originally from Brazil. I had from a family of 10 brothers and sisters. My dad was like a construction work in very low level. And in Brazil, I was able, although my family could not support us to go to college, because in the city where I live, there was a public university, a state university. And I was not that bad of a student. I was okay. So I managed to pass the entrance exam, and that's how I end up doing electrical engineer. So I got my BS there, my bachelor there. I did my bachelor working and going to college, and then I always felt that that sacrificed how I mean my studies. I did not do very well in my undergrad because I had to work at the same time. I was working like most of the half of the time of the day I was working, so I could not study that much. I could not work in projects that much. So when I graduated, I was not very confident on myself as an electrical engineer, as a professional. That's why I decided to go to master. So I decided to enter the master's program, and I work in masters uh, in power electronics. Actually, that was a long time ago, and that was 1991 actually. And then I work with what they called that time DC-DC ZV ZCS converter, which is a low power converter for mainly for power supplies. And then in my master's, I kind of got more self-confident. So the gaps that I had in my undergrad, I kind of complete that gaps during my master, and I felt more confident. And then I found up in Brazil at that time, we could become, you could become a faculty or a professor at university only with the master's. So depends if it was a small university, like from the centers of Brazil, if you go like a far apart, long, like a distant state, you could become a professor in a federal university there. So I applied for the one position and I got the position. Then I worked there for about 3 years as an assistant professor, and then I left Brazil to US to get my PhD. That's when I actually start I would say, my international career. And so this is who I am. I wanna walk you through a little bit of my career, and then I'll present a few projects that I think it's worthwhile you to see the projects in to see as a potential area of work for you. So basically, I'm going to talk about my career timeline. Then I'll talk a little bit about R&D projects, so research project that involves power electronics and power systems. Then I'm going to talk about the congressional reports that I prepared here in the United States. These Congressional reports basically are documents that you prepare and send to the congressman so they can vote a law. So that's why I prepared two of them. And also I did some scoping studies, which is basically there is one area that nobody have touched that, and you wanted to see what are the gaps, what are the recommendations for that area that needs to be developed. So I developed some of that, and then I'll talk a little bit about my profile. If you feel tired of me, just raise your hand and say, João, that's enough. You can stop. So I'm assuming we have 1 hour, right, Jose? Including Q&A, right? Sergio? How long is my presentation supposed to be? Could someone answer to me?
Sí, Joao.
1 hour.
We have until 12 o'clock.
Okay, thanks.
So with questions or something, we could pass some, but it's scheduled to 12
Okay.
o'clock.
So
Don't
let me
worry.
just turn off something here. Just turn off so I cannot get. Just a second.
We have 11.
Okay.
We have 11:12, so it's near
Oh.
1 hour. Yes.
All right. So let's go then for my career timeline. So as I mentioned, I work in my PhD I did here at University of Tennessee in Knoxville, United States. And that was in 1997 when I started, and I finished by 2001. And I did my PhD in power electronics and motor drives. And I use, believe it or not, in 1997, I used artificial intelligence for motor drives. And the project that I was working at that time was for General Motor advanced vehicles. And I was working actually in that time in electric vehicle. So the idea was to try to electrify vehicle. And I work in what they call ZEV3. There was ZEV1, ZEV2, ZEV3, and so on, and so on. ZEV means zero emission vehicle. So the idea of the electric vehicle at that time was not because of the petroleum is going to end at a certain point, but most of us more related to the emission, because if you have emission, the combustion engine based vehicles, of course they have a lot of emissions. And then if you go to the big city, let's say like Bogota, and you have that many vehicles there with emissions, then you make the environment there really bad. Now, if you have electric vehicle and you generate electricity, even if using petroleum, using like a thermal electric power plants, and they are far apart, even if you do that, the emission is spread out, so the nature can't take that, and the big cities are not that compromised. So that was the idea. And then, of course, we are working two different pillars. One is energy storage that was good enough for EV. And the second was to making the EV more efficient. So you could drive more with less battery. So that was the main goal. And I was working in this part mainly, like the motor drive using power electronics. And you know what's important to see that is that at that time, and then it's really important thing, the most challenge load for power electronics was a motor. Motor is a very challenged load because you have regeneration. When you break a motor, you sort of regenerate. The dynamics is very complex, very nonlinear. It's a crazy load. So I think that's why I like that area, the motor drives, because it was the most challenging area. That was back then. Now, if you ask me today, what is the most challenged load for power electronics, I will tell you is the grid. Now, the electric grid, if you think about an inverter, you have, let's say, a PV, and you have the PV inverter, and then whatever you have connected to the PV inverter is the grid, And it's basically is the whole grid then is the load for your inverter, right? Now, the grid is much more complex than a motor, much more complex. You have the imposition of frequency, of voltages, you have short circuits, you have so many problems, so dynamic and such non-linearity that is really the most challenging, and it can kill your converter anytime if you don't control it properly. So that's why I moved from motor drives to grid applications. So today, my main focus is grid applications because those are the most challenging. There are more room for research and development. Okay, so then I did my PhD on this, and then in 2001, I went back to Brazil. I was, as I mentioned, I was a professor before coming for a PhD, and I was in a leave of absence for this get my PhD. And after I finished, I went back to Brazil. When I went back to Brazil for these universities in Mato Grosso do Sul state, it was basically a teaching university. When they say teaching university means you don't have research and development labs there or master's program, PhD program, or anything like that. Basically, what you do, you just have teaching, you just teach classes and you have teaching labs, no research labs. Oh, but I got my PhD and I want to not only teach, I want to do research and development as well. So because of that, I say, well, if there is no facility for R&D, I got to create that. Remember, just want to recall, I'm a kid from 10 brothers and sisters family with a dad that has a very low income, very low. So we barely had food. Why I'm saying that, not for you to feel sorry about me, but basically because of that situation, I learned that I could not expect money from my dad to go to college or to go to a bar or to go to a date or anything. I had to find out the money myself. I had to be independent very as a kid already. So the same thing happened. This background that I had, I brought with me to the university. So because there is no R&D facility there, but I want to do R&D, I say, well, I'm going to create the R&D facility myself. I'm not going to expect that university president or chancellor or whatever rector will create this infrastructure or the facility for me. I'm going to create that myself. So then I decided to create and I plan what I wanted to do. And at the same time, I also want postgraduate students. I want at least master student. So I also decided I'm going to create this master program here at my university. So that was my decision that when I just got back there. Well, 2002, when I had that plan, I said, well, now how can I do that? Because power electronics and motor drives in Brazil has no funding to develop projects there, no funding at all. So R&D at that time for power electronics, motor drives, and electric vehicle was barely in the US. So there is no money in Brazil for that, no funding for research there. So I say if I stay working only in power electronics and motor drive, I'm going to starve to death. I have to become more engineer than just a power electronics or motor drive engineer. I have to be really electrical engineer researcher. So then basically what I did, I crossed the border of power electronics and motor drive. I say, I'm going to go out and work whatever opportunities are out there. And what I did, basically, I say, hey, AI, artificial intelligence, it's a very important and a very powerful tool. And I was right because today you see this is the big hit of the moment in R&D is AI, right? So I was right about that. And then I say, why don't I get these tools, AI tools, and apply in different areas? So then I came to the utilities in Brazil and try to understand what type of problems they had, right? So for example, I'm not sure about Colombia, but in Brazil, there is a lot of fraud in electric system. People steal electricity from the grid. So they bypass the meters, They change the meter settings. They do all kind of things in order to not pay their bill or pay a much smaller bill than it's supposed to pay. So fraud was a big problem in Brazil. Also, a big problem is like at that time, today, most of the meters in the grid in the US for at least are electronics meters, okay? So what means these electronic meters today, you have all information stored, you have communication, and etc. So let's say, for example, let's get someone's in the team here. Let's say you live in a house in a certain neighborhood, okay? So you are connected to a feeder there. And let's say tomorrow, Jose makes me a job offer for me to go to work in Colombia. And yay, that's a country that I would love to live in. So then Jose make me a job offer to be a professor there, and I accept the offer. So I go to the Colombia. I don't know what city are you, Jose? Bogota?
Here in Bogota, just.
Yeah. So I moved to this neighborhood there, and I built a house, and then I wanted to be connected to the grid, right? And then I go to the utility, I say, hey, I wanna be connected because I'm moving here. I'm Joao, blah, blah, blah. And then the utility has one question because they already have that many customers in that feeder. The question they have is like, can we just connect Joao family to the grid now? I'm gonna add a load. Basically, they are adding load. And the feed, because this is a question, important question, why? Because the feeder has the cables, has the transformers, has the protection that they are all the settings, they are designed for a certain amount of load. The question then is like, if I bring João to the feeder, I'm gonna add load. Will my feeder have enough room to feed also João's demand? So the demand of that feeder was a big question. So we got someone, but the problem is, the demand is not only the install power, like the nominal power, because, we have demand curve. In the morning, I have some demand higher, and then in the middle of the morning is lower, at lunchtime increases, in the afternoon goes low, and after end of the afternoon goes very high, peak, and then so that is a variation. And myself probably have a different load curve than Jose, than Sergio, than Tomas, than Andres. So they have different load demand curve. So the question is, how can we compute to see, can we connect João and still have a reliable power quality? I mean, have a good power quality. Can we provide, gonna screw all the system? So that's the question. But at that time, we did not have electronic meters. What we had basically was the electromagnetic meter, basically the one that just rotates and each turn accounts for a certain amount of energy consumed. So if that's true, we don't have any data to estimate what's the load curve of each individual customer and then aggregate that to see how much was the demand for the whole feeder. Like even like identify what's the peak of demand and lower the lowest demand and etc. So we don't have data, we don't have information. So that was the challenge posed by the utility. So I had to come up with some AI techniques to do demand curve estimation. So I was doing then fraud detection, because fraud, going back to that, if someone is stealing power, at least in Brazil, from the grid, the only way for you to fix that, you have to take the cops there, and you have to see them stealing electricity there, and you have to do a flagrant there, see them on the spot stealing, and then you go to the police, and then you have all those paperwork, and then you make the customer pay the utility for all the electricity they stole from the utility. Now, so they had to send people to every single house, or send people, technicians, electricians, to the houses to see if everything was good, if they were stealing or not. Okay, so that's how they do. But every time you send 1, 2, or 3 electricians to a house, you expending money because there are some uh, hours of work focused there. There are some transportation associated with that. So there are many costs involved. So every inspection that you have has a cost. So the question is, okay, so the way how are they doing before? They are just doing randomly uh, random inspection. So they just go, just like randomly pick some customers and go and visit that customers. So the problem with this random inspection is the certainty rate was really low, meaning they're going out there expending a lot of money, but not identifying many people that were stealing or committing fraud. So then my job was, hey, Joao, the question was, hey, Joao, can you come up with a technique or a model or an AI tool that can look at the history of the customer? So let's look at Jose consumption history, where he's sitting, what his power, what type of connection, single phase, three phase, two phases, or if it's commercial or residential or industrial. So based on this data available, can we pre-select the customers to inspect in such a way that our certainty rate is higher, meaning that I gonna go to much less. I have much less inspection, and I'm going to get much more people committing fraud. So my return is gonna be high. So that was. So I'm just saying that to you, so you know that I moved from motor drives and power electronics to the grid, but basically with data analytics and grid using AI, that again back in 2002. Also, I start working with oil and gas industry because they have some problems too, mainly maintenance. And again, I was doing predictive maintenance for them using AI. Basically, was kind of detecting that something was happening mainly to the sensors in the system before they get so bad. So in the very beginning, when they start to drift or have some problem, I would identify and tell the engineer, say, hey, plan maintenance for that thing because that thing is gonna go bad in like 2 weeks or 6 months or whatever. So I could predict when things gonna go really bad. So they have to plan the maintenance in advance. That's for oil and gas industry. I also work with people from biology area, trying to identify the quality of water from other air in like in the rainforest. So in rainforest, we have many small rivers and etc. And you want to know what the water quality there. Again, I was using AI to do that. And also solid waste management. So I just saying that I diversify. I stop working power electrons and motor drives, and then I start to work with grid, with utilities. I start work with oil and gas companies, and all any other people that are demanding any kind of work that I felt that I was capable of. Basically, I did that because I need money. I said, didn't I say that I need to create a facility for R&D? Did I say that I have to start a graduate program? So I need money. So I could not just work in a very narrow band. I kind of expand my areas of work. So when I did that, I start being very successful on this, and I start to getting some grants, some funding. Okay, but I say I'm not gonna wait for the money. In 2003, in university where I was, we have this stadium. Actually, it's the only Brazilian university that has a soccer stadium. And under the seats of the soccer stadium, under the bleachers, there are some space that was like given to students association, but the student association was not really using that. So I went there, I saw that, and then I say I'm gonna maybe remodel this, paint and put some benches and etc., and turn this as my initial research lab. This was again under the stadium bleachers or the seats of the stadium. Because of that, and that was from made of concrete. So under was very hot, really, really hot, dark, and dirt because nobody was using. Student was supposed to use, but they are not using. So there are many bats, like really like the bats living there. So then I kind of invaded that space, get rid of the bats there, and remodel to become my initial lab there. Because there are many bats there, the student would go there to talk to me, and they say, oh, I'm going to go there talk to Professor Joao in the bat lab. So bat lab is because my lab was created there in Brazil in a place that originally was kind of a bats were living there. So we got rid of the bats, and then the student finally start calling bat lab. I liked actually, and then I adopt that was Bat Lab. Bat Lab is a lab that exists there until today. At the same time, I start having the proposals approved. My proposals start to get approved. Then I start to getting money. And then I start to work because we did not have the master program yet. I was just working with undergrad students. Then in 2005, I managed first to write a graduate program proposal to send to the Department of Education, which was approved. And then I start to plan to build my lab because, again, I was using the lab in the stadium, but I want something nicer. Then I start to plan what I wanted to do. At the same time, in 2005, there was this thing called IFEC. Have anybody heard of IFEC's International Future Energy Challenge? It's an undergrad student competition, global competition, trying to solve problems related to energy on the future. Have anyone heard of this ever? Is there anybody out there?
Then that is the same IEEE challenge?
Yeah, it's IEEE challenge, but there are
Okay.
many challenges in IEEE. This one is majorly sponsored by PELS, and its name is International Future Energy Challenge.
Okay. No, I didn't know.
I strongly advise you get familiar with this and build
Okay.
teams there.
Okay.
I built a team there in Brazil in 2005. The goal there was to have an inverter that could have a wide DC voltage range in input and generate a AC output that could be connected to the grid. So that was the beginning of the grid connection converters. That was the very beginning. Nobody had done that before, 2005, and they launched that for a student competition. So I put a team together in my university, and then we actually made to the final event, which was in Denver, and we went there and we compete. There was US teams, there are German teams, Australian teams, there are teams from all around the world, and we were there. I would say the poorest team and the most like youngest team ever. And we went there. We won the award called Educational Impact Award there. Was not that good, but we learned. And then we tried in 2007 again, the second edition, the other edition. And then in 2007, we won the first prize. Brazil, my team, undergrad student from Mato Grosso do Sul that teaching universities, we kicked, as I say here in the West, we kicked ass of big universities like Virginia Tech, Texas A&M, University of Florida, and etc. We did like big work, like strong work, and we got all those prize. And then in 2009, we won the prize again. Then we won 3 prizes: the best work award, like the primer award. Then we won the best design award, and also the best technical presentation. So we won that. And okay, so then after some time, they did not let my team compete anymore. They put me away and said, "Oh, you're gonna win every time, so you are not allowed." Okay, now we phase into 2008 when I already had everything was going well. 2008, I already was getting around $400,000 per year as funding, and I also built already one about 1,000 square meters lab for me there in the lab. We had a lot of equipment in the lab, and I was supporting pretty much 35 students and associate researchers. So then I was like, became, got this infrastructure that I was hoping for. And then going on in my personal experience, then because of my work there in the state, I was invited by the governor to become the Undersecretary for Research and State Undersecretary for Research and Development. Then also became the Dean of the Engineering College. And then I got some Fulbright scholarship. And then I was really involved in IEEE, SOBRAEP, which is Brazilian Power Electronics Society, and Power Electronics Society was my main society where I am involved. And then I got like over 400 R&D projects in more than 200 papers. Then in 2021, I decided to leave Brazil and join Oak Ridge National Lab, where I'm sitting right now. I came here in 2021, September. It's going to be 5 years so far. Since I came here, I became the group leader of the grid system architectures. I lead over 10 R&D projects. I prepared congressional reports and some road mapping. And this is what I'm going to address now. Is there any questions so far? Is it too boring? It's too boring, you can tell me. You're not going to hurt my feelings. Just go ahead and tell me. Say, João, go be more dynamic. Any question? Thank you, Sergio. So let me start with this. This is a feeder, as I was just mentioned. In the past, what the feeder has, you have a substation. We have voltage coming to the substation, power coming to the substation. You have a feeder, you have many nodes in the feeder. You connect the loads like residential, industrial, commercial, etc. And then you put some tap changers to do regulation, voltage regulation, etc. And that was pretty much it. And you could work properly because you have power, all the power. Can you see my mouse?
Yeah.
Let me try to get the pointer.
Yeah, yes, we can.
Let me just try to get a pointer. Okay. Sorry. So basically, you just have power coming from the substation and going to everyone in the feeder, satisfying all the loads in the feeder. But life changed. In the grid, it changed as well. So then people start to come and bring in PVs to the feeder. When they start to bring in PVs to the feeder, you make a big mess. Because before I could control the power flowing from here to there. Now I could not control the power generated by the PVs. So at a certain point of the day, I might as well generate more power than is consumed in the feeder. If that's true, then I have reversal power flow. So I have power flowing from the feeder to the bulky grid. And that's not only problem, because when you have that, you sort of screw all the control. The protection system here is basically for unidirectional power flow. Now you have bidirectional power flow. Now your feeder, protecting your feeder is not an easy task anymore. And even worse, because you're generating too much power here, the voltage goes very high. So you violate the limits allowed by the standards. And you can burn equipment in your customers' equipment because you have over voltage. Or at a certain point of the day, you have under voltage. So now controlling this grid in such a way that is reliable and will not cause any problem for your customers, it's a big deal. I have to control this properly. And the problem mainly is like controlling from the substation. It's very complicated and very expensive because you have sometimes it's better you fix the problem locally. So the question then is, what can I do for this feeder? So then I say, well, let me see. Let's say I want to put some reactive power or active power compensation in this feeder. Where should I put that? So where should I put this, in 1816 or 1834, in the farthest node and the closest node? Where should I site my controllers, feeder controllers, so my active power controllers, for instance? So then I say, well, let me see how this feeder behaves. So I go and I generate many operation points, so scenarios of PV generation and scenarios of load. And I try to see how much the voltage were being violated in all nodes. You see here you have all nodes 800, 802, and so on, and you have middle nodes too, and you have phase A, B, and C. So for instance, for these scenarios, the node 814 phase A violate over 100 times the lowest voltage allowed. And the phase B violated 10, and phase C violated 13. If you go to feed to node 852, only phase A violated like 13 times. So what you see here is that throughout a day, how is your feeder behaving in respect to the quality? So how much is violating the voltage limits and not causing problems to your customers? So I did this for 5%. And then by doing that, I decided I should put some equipments here to do voltage regulation. Let's say between this 812 and 814 and 854 and 852. So basically here I'm putting some compensators here. Now the question is, and also putting some others here too, here and here. So the question now is, how can I control these guys, these four guys I'm putting here, to keep my voltage regulated? Okay, so then I'm gonna skip that. So basically, the point here was I selected the groups and then I create the groups, and then I was able to then do like AI-based control of this. So I have a control center here, like the ADMS sort of thing, that will send active and reactive power references for this equipment so I could keep my feeder control. So, okay, so this was one project I developed. Any question about this? Okay. Now, another project is like, because of these problems, we're gonna definitely need energy storage in the grid. Everyone knows today that people are looking for energy storage to help the grid to deal with the intermittency of PVs and wind and other intermittent resources, right? So energy storage is the way how you can do that. Now, the question is, for example, here we work in 13.8 kV feeder, and our energy storage are based like 400 volts energy storage. Like the battery pack today is around 400, 500 volts package. So how can I then connect this guy to the grid to absorb power and provide power to filter out the intermittencies? So then what we developed was, okay, let's develop a topology and a control that can scale. So for example, you can see here, I can put as many energy storage together as I want. So I can scale in power. And at the same time, I want to directly connected to the medium voltage using an isolation stage, which is not in 60 hertz, is a medium frequency transformer. So I have here a 600 hertz transformer, and then what I gain when I use medium frequency transformer is that I reduce the size of the transformer a lot, actually about 10 times the size of the transformer, and I can manage to install this pretty much anywhere faster, lighter, and I can connect directly to medium voltage AC of the feeder. So this project based it, we developed the topology and we did the modeling using MATLAB Simulink, but also did hardware in the loop using OpenRT platform. So you can do what we call CHIL, is control hardware in the loop. These are the results that we have. So for example, here, in A, we have this line-to-line grid RMS voltage, and we can see here how they are connected and how I'm providing power to the grid and regulating the grid. Here now I'm just absorbing power from the grid. So I'm providing, say, when depends how I wanna at the time of the day. If I have a lot of generation, not so many consumption, then I absorb that power. Now, if I have so much, not much generation and a lot of consumption, I get that energy storage power and I send to the grid. And with that, I help to regulate the voltage there. Another project is what we call medium voltage hub. Medium voltage is basically, consider, for example, you have two AC feeders. You have two feeders here. One is 13.8 one side and another 13.8 other side. So we have two feeders, and these two feeders, one, for example, has a lot of load, and the other is a very light load. So if you're very heavy load, you're gonna compromise again the operation of this heavy loaded feeder. And at the same time, the light feeder is like just sitting there, not doing any job. So the question is, can we connect these two feeders and exchange power? For example, if I have a heavy load in feeder 2, can I provide power from feeder 1 to help to attend that demand? So that's the thing. Can I then interconnect two feeders to do this power flow and make sure they all operate in a acceptable loading level? So that's basically what is go. Now the question again is like, I want to connect this directly in medium voltage AC. I don't want to use transformer. I just want to use directly connections to the medium voltage. So for that, I use CHP, which is cascaded bridge. So this is cascaded H bridge. They are cascaded in such a way that you're gonna add voltage until you reach, for example, 13.8. And then now you can exchange power from grid 1 to grid feeder 1 to feeder 2 and vice versa. With that, again, feeder, again, the grid is my load, and I'm trying to make my grid work better. And this is the controller. So then this is the control that I have. I have many controllers. So from the one side, this grid 1, I want to regulate the voltage here, and I want to exchange power. And from feeder 2, I want to do the same thing with CHB1 and CHB2 respectively. And I have to control my DC link here because I don't want this explode because that can burn my converters. And I want to control the power flowing from one feeder to another. So that's my controller. The only problem is like I'm doing many stuff at the same time. I'm regulating voltage to both sides and I'm exchanging power. So when I do that, if I'm not careful, I can violate the power of my converters and I can burn my converters. So I need a power manager in order to make sure that I never violate the maximum power of my converters and I don't burn my MV hub there. So we did this, here is showing, it's going to take a while, it's showing how the results are. So these are the voltage, these are feeder 1, these are feeder 2. So it's showing the voltage, how is regulated, how is the power flowing, and how are the voltage controlling, etc., showing that it works pretty well. Okay, going to another project. I'm not sure how my time is going. Going to another oh man, I'm already finished my time here. So going to another project, I have this MBB, which is like you are familiar with microgrids. Like microgrid is a very important tool for us to make power electronic, for us to make the grid work. The problem with microgrid though is it's very customized. Everything you have to start a design the microgrid from scratch. So it takes so much time, so much engineer effort, and so much money that people are not deploying microgrid that much. So then we say, why don't we have a microgrid building blocks? So we create building blocks. It's just like a Lego that if you want to build a airspace, airplane with a Lego, right? You get the Lego, you get the pieces, and you put that together, right? So the same thing here. Can we have some building blocks that I can use to build my microgrid in a very fast way, if low amount of engineering time? So that's what we did. So this microgrid basically has a power converter, has a controller of the power converter, and has a higher integration system based in Raspberry Pi. So we developed this architecture and we modeled this also in OpenRT. This is basically what we did, and then this is the controller, and we generate a few results here. I just want to show you that it did a pretty good job here. Another good project is a green steel. Green steel, it's a let's say you want to manufacture steel. The way how you manufacture steel in general, you get coke, which is basically a fossil material, and you put in a blast furnace also along with iron oxide, and then you put in a blast furnace, and then you get the converter, and then you have steel here. So basically, there is a lot of emissions here. It's not a sustainable process. Then people say, hey, we can make it different. We can do direct reduction. And then we can use hydrogen to do that with iron oxide instead of coke in a blast furnace. So when you do that, if you generate hydrogen with clean energy, that basically means you have green steel. So you have steel using iron oxide and hydrogen, green hydrogen. Green hydrogen is basically hydrogen. This is produced using electrolyzers. And the electrolyzer is fed by green energy, such as PV and wind. Problem here is this one green steel plant kind of is in rated power is about 1 gigawatt. So 1 gigawatt is too much damn power. And if you need to do that in US, connected to the grid, it's going to take at least 10 years for you to get approved and connect to the grid. So we want to do this in a different way. Let's do this off grid. So basically I say I have PV, I have wind, I have another PV, and then I can put this together in a power system with a lot of power electronics and send the power all the way to the electrolyzer and then produce the hydrogen here. So this was the project. But to do that, I just showing here one topology, one power system architecture. But you have so many using all these are possible. You have AC couple, you have DC couple, we have only wind, you have wind plus PV, you have so many, you have DFIG technology for the wind, you have PMSG, so you have so many options of architecture. And then how you make it like scale from 10 or 15 megawatt to 1 gigawatt. So you have different way of grouping the electrolyzers. So then we developed this tool. So this tool basically help you to design your green steel platform to produce green hydrogen. Okay, so I think I'm already over the time. I just want to go to my last email, my last slide. Oh, I mean my second last. So I just want to share, based on my experience, my lifetime experience, based in power electronics and motor drives and in AI, I have my profile. And if you ask me today, I say knowledge can be seen as a power spectrum. So here you have the areas of electric for knowledge, for example, let's say in our area, power electronics, motor drives, electric circuits, communication, control, solid components, blah, 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 etc. And then here you have the knowledge, meaning how much knowledge you have in different area. So in general, I divide people into two groups mainly. One is like people that has not so much power, not so much knowledge, but they have knowledge in very wide band. So have knowledge in many different areas. So you know power electronics, you know motor drive, you know AI, you know magnetics, you know power grid, power systems, you know, but you don't have a very deep knowledge on them. So you have knowledge in all areas, but not too deep knowledge. And the opposite, the opposite is when you have knowledge in the very narrow band, but you have very deep knowledge, a lot of knowledge on that. So I say, oh, I'm expert in power electronics converters. So you study power electronics so good that you are the best of the best of the best in the world. So meaning, but if I talk to you about grid, if I talk to you about communication, if I talk to you about AI, you have no clue, you have no knowledge. So this is the second profile. In my case, I developed myself to be on this, to become like as to be like a technology lead. So I have people with this profile working with me, but they are led by me because I have people with different areas working with me here with deep knowledge, and I have knowledge all across the areas, and I can coordinate to reach the goals that I have. And my last slide is the project that I'm most proud of in my career. This is a project I did in Guinea-Bissau, in Africa. These are like this is in Guinea-Bissau in a area like a remote area. There is no electricity there, and there was this women association there, which they have this kind of small horticulture, like small farming, like they could grow tomatoes, lettuce, all these kind of vegetables. And they use those vegetables for their own, for eat, but also they have some surplus that they sell to save some money to pay professors to stay in the area to teach their kids. So these all run by women. Before, they are taking the water from the wells. Here you can see a well by hand and putting containers and carrying a 1 hectare, 1 hectare small farm. So they carrying that. Them, the woman and the kids were carrying like kids like this, were carrying the water all around, very heavy amount of water to water the plants to grow, etc. And they did not have much time for their own or for take the kids, and kids were not going to school most of the time because of that. So my goal there was using power electronics and also some people from civil and architecture engineer to help us to solve their problem. So we developed in my lab a power converter that can drive a motor, that can drive a pump, and whenever, so we have based on PV. So we put here, for example, 4 PVs, and this inside of this there is a inverter that feeds a pump that we put in that well. And this converter, this is a batteryless system, meaning there is no battery there because you say, oh, I have a lot of sun, so let me storage energy in the battery so I can use it later. But the problem is battery is so expensive and it requires a lot of maintenance. And I say, no, we cannot deal with that. This is remote. These people have no money, so we cannot be upgrading this all the time, fixing this all the time. So instead of using battery, why don't we pump water in a tower and we storage the water in a water tank on the high, so the water gets the energy. We store energy in a hydraulic power energy. So we put here water up above, and whatever we need the water, it goes by gravity to wherever we need the water. So now our system then, for any small amount of sun irradiation, will pump our water to that well it's up there, and then the water from the tank will go to the plants and irrigate the plants. So, but another problem is how can we build this tower, because it's very expensive. So that's when we brought together the team from architects and civil engineer, so they could come up with a low-cost solution for power. So this is made what something they call Adobe, which is something that they know how to do this in Africa. So we did all these in 2 months. I went to Africa with my team. You see, this is me, this is my team, this lady, this guy, and we we built this in 2 months. We stayed there 2 months and we built this and we put to run. It's running until today. And then the people now they can have the water going to the plants without having to carry, not put so much burden in the woman and the kids. Here, just of course I always have my good time, so I put some dreads in my hair, and here I was playing soccer with the kids, and then we have this nice picture here. And with that, I'll say I apologize for going beyond my time and for putting so long and have to jump in projects so fast. But I stopped there and I'm ready to answer any question. Thank you.
Thank you, Joao, very much. Thank you very much. This great journey also. Very nice what you and you are an entrepreneurship also. What about your career, your entrepreneur career? You live there?
Yeah. So yeah, as I mentioned, I start back there in my city, my hometown, got my graduation, and I got involved with PELS very much.
Okay.
Because PELS is a very great opportunity for you to, when we are confined in a country, you lose sight of what's going on in the technology. So it's really important for you to be connected. And in professional wise, IEEE for electrical engineer is the best networking forum. And for power electronics and motor drives, PELS, Power Electronics Society, is the best one. So I advise anyone to really get involved. There are many opportunities creating, chapters, student brands, and etc. Volunteering to do many different stuff that we can do. For example, we're gonna have SPEC in 2020, now this year there in Cartagena, and there we're gonna have a woman engineering event. We're gonna have young professional event. We have many very hot like topic top professionals coming to give talks and etc. And that's a great opportunity for you to get involved. So I advise you work with Professor Jose, help to organize, get involved in PELS, and believe me, you're gonna find so many opportunities in your life to go from one undergrad student and become a group leader in a national lab, or president of PELS, or president of IEEE, or if you don't become a president, you're going to be definitely a technical lead in this space. I really I recommend you to do that. I have many experience on that, and I can give you guys all the hints how you can make it work. I can mentor. If you want me to mentor, we can create a group there, and we can have round meetings for just mentoring. I can help you get connected. I can help you go abroad to United States, Europe, Asia, Latin America, any country, to help you to get more international experience and then end up become an international lead, a technical lead, or go back and help your own country, Colombia, to become better and better and better. So that's my message there.
Yes, okay. Thank you very much. Thank you very much. I appreciate this collaboration because for Cartagena, the team is mostly uh, made from students. So I'm very happy for the spec logistic uh, committee. I leave the floor for the questions. I prefer to give them the word to someone.
You can ask any question, don't have to be related to the projects. I know I passed through fast, and then you may not have a specific question, but you have general question, feel free to ask. I'm not saying I'll be able to respond, but I'll definitely try.
Sí, yes, thank you.
And you can ask the question in Spanish you prefer, no problem. I can understand if you speak despacito.
That's very okay. Eso es muy bueno. Sí, claro. Preguntas en español se pueden también. Chicos.
Okay. Thank you. Anyway.
Listo, están tímidos los muchachos. Bueno, Valentina, hay una pregunta aquí que puedo leer. Te dice, where did you find the opportunity to help with a social project in Africa?
Okay, that's a good question.
Yes.
This one was sponsored by Brazilian government. In the past, there is this Brazilian government, they create this call for proposals for Brazil-Africa cooperation. And that's when I start. But since then, I'm submitting proposal because there are so many opportunities out there. For example, I'm not sure if you already heard about Nexans. Nexans is basically a conductor manufacturing. They have this call for proposals. I just submitted a proposal for Instituto. It's a Portuguese institute. Had a call too, and actually it was supposed to be a Ibero, was Spanish speakers and Portuguese speakers for Portuguese speakers in countries in Africa, and we prepared a proposal, and now we're waiting for the response. So there are opportunities there. I can, if you are interested, I can definitely, whatever opportunity I see, I can kind of share with you, and we even write proposals together because I still love doing this. I mean, again, as I mentioned, this is my favorite type of work. This most important work in my life, for sure, that made me more satisfied with myself professionally. That was. So if you are interested, let's keep in touch. Whenever opportunity comes up, I can share. We can put a joint project. You can just write your own project any way you prefer.
Okay. Thank you very much. The question was made by Valentina. It's okay for you, Valentina? Okay. I think that when I went to Johannesburgo last last December, is that we have no collaboration between South between Africa and Latin America. So it's I think it's very good opportunity to fill the gap between the two continent and subcontinent because we need is I think there is many Colombian students, and I am sure that here in this audience are very interested in this type of project. So I appreciate your collaboration in this domain.
I'm definitely willing to collaborate to bring you guys to the picture. If you guys are interested, whatever opportunity I see, I'll reach you out and see if we can do together, because it's really important, this south to south connection. Yes.
Yes, thinking of that, we plan to the next no, was maybe the first official technical meeting of the SPEC 2026. And the technical committee, I would like to invite you to the committee, because I would like to many of the, such as I said before, most of the team, of the logistic team for SPEC 2026 are students and are maybe is on today here. Heard us. So I would like to make in Spanish. So I thought to invite Wilmar and to invite also Mario Pacas. And I think that you can be there because you speak in Spanish to make a committee in Spanish, so you can meet these guys also here, the students. It will be nice.
Okay.
Opportunity to talk about.
I'm be very happy to. Very happy to.
Okay, thank you very much. Valentina says yes. Thank you very much. Okay. I don't know if there is another question. Sergio, you...
No, Professor, I'm okay with that.
Okay. So before say goodbye to Professor Joao, I would like to remember you that this afternoon we continue the event with presential presentations and hackathon also, and also cocktail later. So see you this this afternoon.
Too bad I'm not there.
No. We have to plan a real another cocktail to have you here between us. Thank you very much, Joao, for your presentation. Very nice presentation. So thank you very much. And I say you goodbye and thank you. I will be in contact with you also. Thank you very much.
Well, all right. Thank you.
To everybody also, thank you very much for your assistance today. Thank you.
Thank you.
Muchas gracias a todos.
Muchas
Gracias, Joao.
gracias.
Okay, bye.
Thank you very much.